we're going to finish up chapter 6 today. Yay, right? It's been a long chapter. The last thing we're going to talk about is what they call aromatic hydrocarbons. They're a ring, plus they have alternating double bonds, double and single bonds. And they're called aromatic, part of it because they're very smelly. They're very, they use them in scents, okay? The compounds are later found to have a unique unsaturated hydrocarbon ring, and that's what I was talking about. It's a 6-carbon ring, and it has alternating double bonds. And we don't call it 1, 3, 5. That would be 6-cyclohexyltriene. No, you don't have to do that. All they do is call it benzene. Simple benzene. That's it. So if you see a ring of 6 with alternating double bonds, or sometimes they just write a circle in the middle, that's benzene. Okay. Example is vanilla. Vanilla, oh shoot, you can't see it. There's a benzene ring right here and it has other things stuck on it. But vanilla is an example of a benzene ring. Okay. And I'm sorry, I'm kind of covering that up. But anyway, aromatics have benzene. Okay. So benzene is a 6-carbon ring with 3 double bonds and 3 single bonds. Okay. The electrons are allowed to move kind of all over, and they're the same length. The bonds are the same length and strength, so they rotate. So they say they're delocalized. They're allowed to move, and that's what gives them their special characteristics. Okay. All the bond angles are 120, so they're even. They're rigid, they're flat. Not one bond is different than another. Okay, and here we have it. Here's benzene. Sometimes you'll see it like this with just the alternating bonds. Sometimes they'll just draw it in, or sometimes a circle. I guess this is what I see most often because this tells me the bonds are moving. But if you see any of these structures, you know it's benzene. You just call it benzene and that's it. Okay? All right. So what about these benzenes? Okay, benzene is the root name. Okay? So when you have aromatic hydrocarbons, you have benzene. And again, you don't have to write its fancy name, just say benzene. When you stick stuff on it, when you put substitute groups on it, you name them just like you did if you had a chain with a group stuck on it. You look at the number of carbons. If there's 1, it's methyl. If it's 2, it's ethyl. If there's 3, it's propyl, and so on. And if it's on the very first one, you don't have to write, you don't have to put a number in because it's a ring, and rings always start wherever you want. So that's always considered the first one. So here's an example. Here's methylbenzene. Okay, it's on the first one. And again, this is a benzene ring. Now here's a 2 carbon, that's ethyl. So it's ethylbenzene. Here's a 3, and you can't see the benzene very well, sorry about that. But this is propylbenzene. Okay, so these are substitute groups. There's only one of them. So you don't have to write a number because, again, it's a ring, so you can start numbering anywhere you want. But if you end up with one with 2 substitute groups, now you got to use locator numbers. You got to say where they're at, okay? The numbering begins at the first substitute, and then you want to either go clockwise or counterclockwise, depending on which one gives you the lowest possible numbers. So it's always important that you want that. And then when you're putting them in the name, they always go in alphabetical order. Let's say you have a propyl group and a methyl group. Methyl would come first and then propyl. It doesn't matter if there's like a di or tri in front of those. Those don't count for the alphabetical order. Okay? So if you have an ethyl, a methyl, and a propyl, ethyl comes first, alphabetical, then methyl, then propyl. So you put them in according to alphabetical order. Okay, here is a benzene ring. And we got, say we're going to start here with ethyl, and then we're going to number this way because we get smaller numbers that way. So we're going to go 1 ethyl, 3 methyl benzene. Now, if you went 1 methyl, or if you went 3 ethyl, 1 methyl benzene, that would be proper too, because again, they're, 1 and 3 are the orders, but this is a benzene ring, and so you just write benzene. You don't have to write out the fancy name, okay? When you have 2 or more identical substances, and again, then you use the multipliers like di, tri. If there was 4, you use tetra, okay? They do have a system with benzenes where they use the word ortho. Ortho means the first and second. Meta means the first and third, and para means the first and fourth. I'm just showing them to you. You don't have to worry about it. We're just going to go with 1,2 dimethylbenzene, 1,3 dimethylbenzene, 1,4 dimethylbenzene. And again, these would all be isomers of each other because they have the same amount of carbon, same amount of hydrogen, and that kind of stuff. Okay, but again, we'll just stick with the locators. These, you'll see these sometimes. Don't get confused by them, but we're just going to go with the numbers. Okay. Okay, so what happens if you have a benzene on a group? And let's say it's one with a double bond or one that has substitute chains on it. Now benzene isn't the main group. Benzene is a substitute group and it's stuck onto a chain, and that can happen. So what you do when that happens is you give it a name like a substitute group. You call it phenyl. You think it would be benzyl, right? Because it's benzene, it'd be benzyl. It's not. That would be too simple, I guess. So they call it phenyl if it isn't, on all of these, benzene was the main thing and you had stuff stuck on it. But now we're going to have a chain on here with maybe a double bond or a triple bond or has we don't know how to name a substitute group with a double bond, and we actually don't because the double bond now becomes the main chain and this is stuck on it. Okay, so what happens again if we have a substitute group and on your benzene group you have one with a multiple bond like a double or triple bond? Again, we don't have a name for those as a substitute group. They aren't a substitute group. The benzene becomes a substitute group and they call it phenyl. Excuse me. So here we have our chain and we got a double bond in there. So this becomes the main group right here. We have 1, 2, 3, 4. Okay. So, and we have a double bond on the second one. So that would be 2-butene. Okay. And then to name these guys, on the second and the third, we have methyl groups. And then this is a phenyl group. Okay. And again, the double bond gets the precedence for having the smaller number. So this is actually a 4. So 2,3-dimethyl. And again, methyl comes first because alphabetical order. Okay, so I put my 2,3-dimethyl in here. 4-phenyl. That's my benzene ring, but now it's not benzene anymore because it's not the main chain, it's phenyl. And then 2-butene. There's a double bond on the second one. Okay, so again, the name tells you everything. Okay, here's 2,3-dimethyl. There's 2 methyl groups on the second and third carbon. There is a phenyl group. This is phenyl because now again, it's not benzene anymore. It's phenyl because it's not the main chain. And then we've got a ring or a chain of 4, and it has a double bond on the second one, so that's butene. And that's how you name it. Okay? And I do believe we are done with chapter 6, I think. Yep. Okay, so now we're done. I'm going to put in a couple of worksheets where I have the answers for you, just so you can go through them. They're there for you to help you study or whatever. I'll scan them in. I put the answers. I just wrote them in. I'll attach these, but you'll also have an assignment with the aromatics. And that's it for chapter 6. We don't have a test yet. We have to do chapter 7 as well. Chapter 7 now, we're not just going to be carbon and hydrogen. We're going to add some other stuff in there. So then we'll be done. So much for chapter 6. Goodbye, chapter 6.